All right, 31. A market researcher chooses at random from women entering a large suburban shopping mall. One outcome of the study is a 95% confidence interval for the mean of the highest price you would pay for a pair of casual shoes. So they found a confidence interval for the average of the highest price you would pay for a pair of casual shoes. Explain why this confidence interval does not give useful information for the population of all women. In other words, can you generalize this to all women? And the answer is no, you cannot generalize. And why not? Well, what was our sample of women? Our sample of women were women chosen at random that entered a large suburban shopping mall. So the sample were women entering a suburban mall. So since this is my sample, I can generalize it to this group of women, right? To all women who shop at suburban shopping malls, right? Can I do it that way? Because who have I excluded? I've excluded women that don't live in suburbia. They're not part of it. So how could they be part of this sample? They might not pay as high a price for casual shoes and so forth. Does that make sense? So it's really a biased sample because just a convenient sample. Okay, that's A. B. Explain why it may give useful information about the population of women who shop at large suburban malls. Well, I think we just answered that question. Because my sample was for women entering suburban malls, then I maybe could generalize it for the population of women who shop at suburban malls. Although you would still have to be cautious because it's still just a convenient sample for the women entering this one particular shopping mall. And yes, they were chosen at random. My question is, did all of the ones that were chosen at random actually participate in the interview? I mean, if we assume they did, then that's a little bit better. Um, and so you could kind of go from there. So that's why the big may right there. All right, 32. You want to estimate the mean load needed to pull apart pieces of wood in 1450 to within plus or minus 1,000 pounds with 95% confidence. Okay, how large of a sample is needed? Well, x bar plus or minus z star sigma over square root of n is my confidence interval. This is the margin of error. And I want that to be on my estimate to be within 1,000 pounds. So I want z star plus or minus sigma over square root of n to be, I would set that equal to 1,000 and figure out what n has to be. So for a 95% confidence interval, that's 1.960 times, I have to look up what sigma is, and I want that to be 1,000. So I'm going to figure out what n is. So sigma for in exercise 1450, I'm looking that up right now. Sorry about that. Standard deviation is 3,000 pounds. Okay, so solve this for n. Divide by 1.96. Make sure you're comfortable doing this. 1,000 divided by 3.96, or 1.96, sorry if I said 3. 510.2. Again, leave that in your calculator. Multiply by square root of n. divide by that number. 3,000 divided by 510.2. So 3,000 divided by my answer, 5.88. Again, don't round until the very end. Square both sides, and you get n is 34.57. That exact number gives you 1,000. So I want to make n bigger, because then the denominator is bigger, which makes, when you divide by a bigger number, the whole number gets smaller. So then my margin of error will be smaller than 1,000, which is what we want. Okay, so if n equals 35, the margin of error is less than 1,000 pounds. Okay, there we go on that one.